Hello math lovers, today we'll learn about HCF and LCM. First HCF and then LCM. So what exactly is HCF? So HCF stands for highest common factor. It is also called greatest common divisor, GCD. HCF is used for two or more numbers to get the greatest number which divides all the given numbers without any remainder. Example, if we have 12 and 30, our HCF is 6. 6 is the greatest number that can divide both 12 and 30 without leaving any remainder. So to make it more clear, we have numbers 12 and 30 in our example. So for number 12, there are several factors of 12 like 1, 2, 3, 4, 6, 12, and there are also several factors of 30 like 1, 2, 3, 5, 6, 10, 15, 30. So 12 and 30 has several factors, but some of the factors are common to both 12 and 30, like 2 is the common factor of 12 and 30, 3 is also a common factor of 12 and 30, and 6 is also a common factor of 12 and 30. So from among these common factors 2, 3 and 6, 6 is the greatest. So the factor which is the greatest, that is 6, is the HCF of 12 and 30. Now friends, we have known what is HCF. So our question is, how do we find HCF? So we have three ways to find HCF. Number one is factorization method, number two is prime factorization method, and number three is division method. So first we will go to the factorization method. So what is factorization method? So in factorization method, all the divisors or factors of the given numbers are written, and then the common divisors among them is marked, and the greatest among them is selected as HCF. So we'll use an example to understand the factorization method. For example, we want to find the HCF of 12 and 30. So we'll first find out the divisors of 12 and 30. So the factors of 12 is 1, 2, 3, 4, 6 and 12. We can write down all the divisors of 12 by this method also, like 1 into 12 is 12. 2 into 6 is 12, 3 into 4 is 12. So in this way we can get all the divisors of 12. Similarly, we can also get the divisors of 30, like 1 into 30 is 30, 2 into 15 is 30, 3 into 10 is 30, and 5 into 6 is 30. So we have all the divisors of 12 and 30, and we see that 2 is common to both 12 and 30, 3 is common to both 12 and 30, and 6 is also common to both 12 and 30, but the greatest among these are 6. So 6 is the greatest. So HCF of 12 and 30 is 6. Our second method is the prime factorization method. So in this method, all the prime factors of the given numbers are written. Then prime factors common to all the given numbers are marked. And then these common prime factors are multiplied to give HCF. So we again take the same example, that is we want to find out the HCF of 12 and 30. So we first write down the prime factors of 12, that is 2 into 2 into 3. And we write the prime factors of 30, that is 2 into 3 into 5 is 30. So we see that 2 is common to both, and also 3 is common to both. So 2 and 3 are common factors. So 2 into 3 is 6. So HCF of 12 and 30 is 6. The last method is the division method. So in this method, from among the given numbers, one smaller number is taken as divisor and another larger number is taken as dividend. Then the division is performed. Then the remainder becomes the new divisor and the previous divisor becomes the new dividend. In this way, division is performed until remainder is 0. The divisor of the last division is the HCF. So we'll make it more clear with the help of an example. So we want the HCF of 12 and 30 using the division method. So 12 is the smaller number from among these numbers. So we'll take 12 as the divisor and we'll take 30 as the dividend. So 12 into 2 is 24. So 6 is left. So this becomes the divisor and the old 12 divisor will become the dividend. So 6 into 2 is 12. Now we have got the 0. So we'll stop it here. So this 6 divisor becomes our HCF. So the HCF of 12 and 30 using the division method is 6. Friends, we have covered the HCF. Now let's jump into LCM. So what is LCM? LCM stands for least common multiple. It is used for two or more numbers to get the smallest number that gets divided by all the given numbers without any remainder. It is the least number that is a common multiple of all the given numbers. Example, if we have 12 and 30, 60 will be our LCM. 60 is the least number from among common multiples of 12 and 30. So for your clarity, in our example, we have two numbers 12 and 30. Now this number 12 may have several multiples like 12, 24, 36, 48, 60, 72 and so on. And the number 30 also has several multiples like 30, 60, 90, 120 and many more. So the point where they have a common multiple, that first number is the LCM of these two numbers. There may be several common multiples, but the first common multiple is the LCM of that two numbers. Now our question is how to find LCM. So we can find LCM using the similar methods, that is factorization method, prime factorization method and division method. So first let's go to the factorization method or multiples method. In this method we have to write the multiples of the given numbers and then we'll mark the first common multiple, and then that first common multiple will become our LCM. For example, let's find out the LCM of 12 and 30. So first we will write the multiples of 12, that is 12, 24, 36, 48, 60 and 72 and so many afterwards, but this much will be enough. Then we'll write the multiples of 30, so 30, 60, 90, 120 and so on. So when we see carefully that our first common multiple is 60, so 60 will be our LCM of 12 and 30. Our second method to find out LCM is prime factorization method. In this, prime factors of the given number are written, then each prime factor with its highest power in any given numbers are multiplied to get the LCM. So let's find out the LCM of again 12 and 30. So we'll write the prime factors of 12, that is 2 into 2 into 3, that is 2 to the power 2 into 3. And we'll find out the prime factors of 30. So prime factors of 30 is 2 into 3 into 5. So here we see that the highest power of 2 is 2 to the power 2. Then we'll take 3. So the highest power of 3 is only 1, and we'll take 5. So the highest power of 5 is only 1. So we have to take all the prime factors that we can see, and we'll then find out the highest power of each of them. So in this way we get 2 to the power 2 multiplied by 3 multiplied by 5. So the answer is 60. Therefore the LCM of 12 and 30 is 60. Now we'll move to the division method of finding the LCM. So in this we'll divide all the given numbers with prime numbers. We'll start with 2 until the numbers are divisible, then 3, then 5 and so on until the remainders are 0. We'll then multiply all the prime numbers to get the LCM. So let me make it clear with the help of an example. For example, we want to find out the LCM of 12 and 30. So we'll write 12 here, we'll write 30. So first we'll use 2. Suppose that they are not divisible by 2, then we can write 3. But 12 and 30 is easily divisible by 2. So we'll start with 2. 2 into 6 is 12. 2, 15, 30. So we have 6 and 15. So again this will go by 2. So 2, 3 is a 6 and 15 will be 15 because not divided by 2. So 3 into 1 is 3 and 3, 5 is 15. So we see that it is not divisible by 3. So we'll use 5, our next prime factor. So 1 will be 1 and 5, 1 is 5. So now since we have all the numbers as 1, so we'll multiply all these numbers to the left. So 2 into 2 into 3 into 5 is 60. Therefore LCM of 12 and 30 is 60. So friends, we have learned about HCF and LCM. We have also learned 3 ways to get LCM and HCF. Now I'll tell you about the relationship between LCM and HCF. So there is a relationship between LCM and HCF of 2 given numbers. It will not work with more than 2 numbers. It will only work with 2 numbers. For example, say we have 2 numbers A and B. So the LCM of A and B multiplied by the HCF of A and B will always be equal to the product of A and B. For example, we have LCM of 12 and 30 multiplied by the HCF of 12 and 30 equals to the product of 12 and 30. So LCM of 12 and 30 is 60, HCF of 12 and 30 is 6, and the product of 12 and 30 will be 360. So 60 into 6 is also 360. So the above relationship has been proved. Another 2 obvious and very important point is that the HCF of given number is always smaller or equal to the given number. This is because HCF is a factor and factors are always smaller or equal to the given numbers. Second is LCM of given number is always greater or equal to the given numbers. This is because LCM is a multiple and multiples are always greater than or equal to the given numbers. Friends, I am hopeful that you have understood LCM and HCF very well. I am going to present you some more examples using the three methods, that is factorization method, prime factorization method and division method. This time I will be using three numbers. So let's find out the HCF of 45, 60 and 72 first using factorization method. So we'll write down the divisors of 45, 60 and 72. You can see the respective divisors here. So when we see carefully, we can see that only 3 is common to all the divisors. So 3 is our HCF. Then we'll go to the LCM of 45, 60 and 72. So in this case, we'll write out the multiples of 45, 60 and 72. So you can see there are several multiples of each of these numbers, but the first common multiple is 360. So our LCM of 45, 60 and 72 is 360. Then we'll move to the prime factorization method. So we'll find out the HCF of 45, 60 and 72. So we'll write out the prime factors of 45, 60 and 72. So for 45 it is 3 into 3 into 5. For 60 it is 2 into 2 into 3 into 5. For 72 it is 2 into 2 into 2 into 3 into 3. So we see that only 3 is a common prime factor of all these three numbers. So we have the HCF of 45, 60, 72 equals to 3. Then we'll move to the LCM of 45, 60 and 72 using prime factorization method. We'll write the prime factors of 45 as we have already written in our HCF. So prime factor of 45 is 3 to the power 2 into 5. Prime factor of 60 is 2 to the power 2 into 3 into 5. Prime factor of 72 is 2 to the power 3 into 3 to the power 2. So first we will find out the greatest power of 2. So the greatest power of 2 is 3. Then we'll go to 3. So our greatest power of 3 is 2. We'll go to 5. So the greatest power of 5 is 1. So 2 to the power 3 multiplied by 3 to the power 2 multiplied by 5 to the power 1 will be 360. So the LCM of 45, 60 and 72 will be 360. Finally, we'll jump into the division method. So according to the division method, how we'll find out the HCF of 45, 60 and 72. So we'll take the first two numbers, that is 45 and 60. 45 becomes our divisor and 60 becomes our dividend. So 45 into 1 is 45. So if we subtract, we get 15. So we'll take this divisor as a dividend. So 45 into 3 is 45. We get 0. Now we have one more number left. We cannot say 15 is the HCF. We have one more number left, that is 72. So we'll take 15 as a divisor and we'll take 72 as a dividend. So 15 into 4 is 60. So if we subtract, we get 12, and we'll bring this 15 as a divisor. So 12 ones are 12, and we subtract it, we get 3. We'll bring this 12 as a divisor again. So 3 into 4 is 12, we get 0. So finally we have HCF of 45, 60 and 72 as 3. Now we'll find out the LCM of 45, 60 and 72 using division method. So in this method, we'll first write 45, 60 and 72, and then we'll make a table. So first we'll take 2. So 45 is not divided by 2. 60 divided by 2 will be 30, and 72 divided by 2 will be 36. Then we'll again take 2. So 45, 15 and 18. So again we'll divide by 2. 45, 15 and 18 will be 9. So now it is no longer divided by 2. So we'll take 3. 3 into 15 is 45. 15 will be 5 when divided by 3, and 9 will be 3 when divided by 3. Again we'll take 3. So 3 5s are 15, and 5 will come down, and 3 into 3 1s are 3. Now it is no more divided by 3, so we'll take 5. So 5 will become 1, again 5 will become 1 here, and 1 will become 1. So all are divided, and we have 1 1 1 in our last row. So we'll multiply all these numbers. So 2 into 2 into 2 into 3 into 3 into 5, that will be 360. So our LCM of 45, 60, 72 is 360. So friends, in conclusion, I want to say that I have tried my best to make you understand. I have given examples to aid you to understand the concept better. If you think that you like my video, you can press that like button. Please subscribe and share this video to motivate me. There are several friends who just watch video but do not subscribe. So I request you, please subscribe the channel so that more knowledgeable and beautiful videos will be available to you easily. Thank you.